Good morning, children. Today we will continue to discuss the chapter quadratic equations. As we know that standard form of quadratic equation is ax square plus bx plus c equals to 0, where a is not equals to 0. By this we can find the value of a, b and c. For example, 2x square minus 4x plus 3 equals to 0. This is an quadratic equation. Now if we compare these two equations, we can find a equals to 2, b equals to minus 4 and c equals to 3. To find the nature of roots, first we have to calculate discriminant denoted by capital letter D equals to b square minus 4ac. Now again, if we take this example, here b equals to minus 4. So it will be minus 4 whole square minus 4 into 2 into 3, which will be 16 minus 24, which is equals to minus 8. So value of discriminant D is minus 8, and it is minus sign, so it means D is less than 0. So first condition is, if D is less than 0, then there are no real roots. No real root means we cannot find the value of variable, that is x, in terms of real number. Now suppose if the value of D, that is discriminant, is positive, so it is greater than 0. So if D is greater than 0, then there are two distinct real roots. Then we can find the value of x in real numbers. And third condition is, if D equals to 0, then again there are real roots, but both are equal. So two equal real roots. After finding D, now if there is D greater than 0 or equals to 0, then we have to find the value of x, that is roots, by using quadratic formula. So quadratic formula is x equals to minus b plus minus under root d upon 2a. So this is quadratic formula. Exercise 4.4, question number 1. Find the nature of roots of the following quadratic equations. If the real roots exist, find them. So in case, in all the three parts, if D is less than 0, then we do not have to find the roots. We will just write no real roots. So for example, question number 1, second part, 3x square minus 4 root 3x plus 4 equals to 0. Now, if we compare this equation by quadratic form, ax square plus bx plus c equals to 0, then value of a is 3 value of b is minus 4 root 3 and value of c is 4. First we have to calculate discriminant d. So d equals to b square minus 4ac. Now b is minus 4 root 3. So minus 4 root 3 whole square minus 4 into a into c. Now minus square is plus, 4 square is 16, root 3 square is 3. So 16 into 3, 48. Minus 4 3s are 12, 12 4s are again 48. So 48 minus 48, which is 0. So value of b, that is discriminant, is 0, which implies that two equal and real roots exist. Now if two real and equal root exist, we have to find them. So for finding roots using quadratic formula, x equals to minus b plus minus under root d upon 2a. So x equals to minus b, minus minus plus. So plus 4 root 3 plus minus d is 0, discriminant d is 0 upon 2a. So 2 into 3. So which is equals to 4 root 3 upon 6. Now we can cancel out 2 2 is 4, 2 3 is 6. So x equals to 2 root 3 upon 3. So this is the root because d equals to 0. So there are two equal and real roots. So both the values are same. So x equals to 2 root 3 upon 3. Second question, find the values of k for each of the following quadratic equations so that they have two equal roots. So in this question, it is given that they have equal roots. Open the bracket. First we have to convert the given question into standard form. So kx into x is kx square minus kx into 2 is twice kx plus 6 equals to 0. Now if we compare it with standard form, ax square plus bx plus c equals to 0, we will get a equals to k, b equals to coefficient of x, that is minus 2k, and c equals to 6. Now to calculate d, b square minus 4ac. So b square means minus 2k square minus 4 into k into 6. So minus 2k square is 4k square minus 24k. So this is the value of d. But it is given in the question that two real and equal roots exist. So for real and equal roots, condition is d should be equals to 0. So value of d is 4k square minus 24k equals to 0. So 4k square minus 24k will shift right hand side. So it will be 24k, 1k cancel out. So k equals to 24 upon 4, which is equals to 6. So k equals to 6. Question number 5. Is it possible to design a rectangular park of perimeter 80 meter and area 400 meter square? If so, find its length and breadth. So perimeter is given 80 meter, area is given 400 meter square. So perimeter of rectangle is twice length plus breadth, which is equals to 80 given. So length plus breadth equals to 2 will come here, 80 upon 2 equals to 40. And area is given 400 meter square. So area of rectangle is length into breadth equals to 400. Now from these two equations we have to find the length and breadth. So length will be equals to 40 minus b. Now if we put in place of length 40 minus b, so second equation will be 40 minus b into b equals to 400. Multiply it, so it will be 40b minus b square minus 400 equals to 0. Writing down in standard form and taking minus common, so it will be b square minus 40b plus 400 equals to 0. Now you can solve it either using quadratic formula or by splitting the middle term. So b square minus 20b minus 20b plus 400 equals to 0. b common, b minus 20 minus 20 common, b minus 20 equals to 0. So b minus 20, b minus 20 equals to 0. It is b minus 20 whole square equals to 0. b minus 20 equals to 0. So b equals to 20. So breadth is 20 meters. Now we have to calculate length. So putting the value of b here. So length will be equals to 40 minus 20. So length is also 20 meter. So length is 20 meter, breadth is also 20 meters. So yes, it will be a rectangular path because length and breadth are same. So it is a square, but a square is also a type of rectangle. So today's homework is you have to complete exercise 4.4, question number 1 to question number 5. Thank you.